Hi, everyone. Thank you, Michelle, for the introduction. And I'm here to tell you a little bit about yourself. Now, when you think about who you are, you probably don't think about your immune system, but I do quite a lot. And I think we all should. So I'm going to tell you about yourself through the immune system. Now, this is the second most complex organ in your body. The brain wins that one. It's the largest, most widespread throughout your body. It's the only mobile system. A cell coming from your chest can fight infection in your toe, come right back up, and it keeps you alive. It's the only one that can kill you in about 15 minutes at the mere touch of a peanut. And it's really important. Ultimately, it separates you from everything else in the universe. Now, I became fascinated with the immune system at a really young age. It led me to study immunology at McGill University and then joined the National Institute of Allergy and Infectious Disease after school. And the more I learned about the immune system, the more confused I became. It became really difficult to convey, impossible to talk to people. I even became frustrated with how science talks about the immune system. And so I developed 3 tricks to talk about the immune system. And the first one is to blow up this micro world into a whole universe. And at the center of this universe is planet U. And then you have to give these cells character. There's a lot of them, and they all have different personalities. A lot of them are extremely violent. And this is how I remember some of these crazy cells. And then the third is to make it personal. I have my own personal story with it. And these cartoons also make it incredibly personal, I think. So we're going to start with planet U. You are a planet. You're home to 14 trillion human cells. And in fact, you're also home to even more bacteria, viruses, fungi, protists. In fact, there are more bacterial cells in your body than human cells. And so on planet U, you're at a bit of a disadvantage with these bacteria. They can divide very quickly. They evolve very quickly. In fact, with unlimited resources, E. coli can divide every 20 minutes. And in a couple of days, this ball of E. coli is the size of our actual galaxy, which is pretty amazing. Now, with this disadvantage against bacteria, you need an army. And this is where your immune system comes in. And the guardians of planet U are these immune cells. It's very complex. And this is actually a condensed version of the immune system, but it shows all the many interactions. There's attack, killing, they have to activate other cells, communicate. And so let me break this down a little bit more for us. There are 2 branches to this army. On the left, we have the innate immune system. These guys are always ready to fight. They're your front line. They're tissue specific, so they can live in the skin. There's specific cells that live in your brain, in your lung. And they're vital against parasites, initial infection against viruses, fungi, and all sorts of things. So let's meet one of these cells. We're going to start off with the macrophage. The macrophage is very aptly named. Macro means big, phage means eat, and they eat pretty much everything. They'll go in and eat some bacteria. They also eat fat and cholesterol in your arteries. The ones that live in your brain eat plaques that are implicated in things like Alzheimer's, Parkinson's. And yeah, their job is just go around eating things. So here it is in actual life. This is what it does. That's a couple hundred bacterial cells that one macrophage can mop up all by itself. But the innate immune system has some limits to it. It is considered broad or general immunity. Therefore, it's not specific. It really responds to chemical signals of infection. And it can be overrun in a matter of a couple of days. Due to this broad or general immunity, it's not specific towards a specific pathogen. And another downside is collateral damage. These cells, they, as I mentioned before, are quite violent. In fact, they have no regard for you or your own human cells. So to introduce this is the neutrophil. Now, neutrophil, neutro meaning neutral, phil meaning loving, but he is anything but neutral loving. At the mere sight of a bacteria, this guy will blow himself up and kill everything around him, including your own cells. In fact, for severe COVID-19 infections, It's not the virus that is doing the most damage. It's actually these guys in your lungs constantly blowing themselves up, and that does the destroying of your lungs. So we turn to the second branch of our army, the adaptive immune system. So these are made up of T cells and B cells, and they are insanely powerful. So they take 10 to 14 days to arm, which is where your innate immune system takes over those first few weeks. But once they're ready to fight, they're ready to fight forever. Their effects are long lasting, and that's due to a few key attributes. But before I get into that, the most important thing about the adaptive immune system is that it makes you immune to every disease. Things from coronavirus to the Spanish flu, even the first bacterial infection on Mars. And how that happens is through a couple of specific things. So the T and B cell, they create memory. Once they see an infection, they'll remember it forever. They take basically a snapshot, put it up on the most wanted wall. They're ready to attack that pathogen again. They're also specific. In your body, there is one T cell that fights coronavirus. There's one T cell that fights the common cold. There's one B cell that fights streptococcus pneumonia. And with one cell fighting one pathogen, you need infinite cells to do that because there are infinite pathogens. So these cells, in a topic that deserves its own talk, are able to mutate their DNA and fight anything they want to, including things like peanuts, or shrimp, or even yourself. So there are some drawbacks to this infinite adaptability of your immune system, and it makes you finely balanced, and you must be finely balanced. Too little immunity, infections. Bacteria will overrun, they'll keep growing, or cancer. Too much, and you get allergies, or autoimmune diseases like lupus. And so the immune system is easily ticked off in one direction or the other. And a good example of this is a single mutation. So here we're dealing with the X chromosome and a single letter switch from A to C in this location. So now instead of having pink and purple, you have blue and orange in this one spot. This leads to a disease called X-linked agammaglobulinemia, which I write like that because by the fourth syllable, it looks like a doctor's prescription note. And what it means is X-linked on the X chromosome. Agammaglobulinemia just means no antibodies. So this is the immune deficiency that I have. And what happens in XLA is that this protein called BTK is no longer produced in B cells. I wish I had a funny comic for this, but I was running out of time. And so I took this slide from someone who presented at my nonprofit. And you can see on the top left, you have your B cells without BTK. And then on the bottom are normal B cells with BTK. And BTK is basically a driver's license for these B cells to leave the bone marrow, go into the spleen, and fight infections throughout your body. So without BTK, they're stuck in the bone marrow, and I pretty much just have baby immature B cells that only stay in my bone marrow and unable to fight anything. So what happens when you have XLA? Well, many infections. When I was young, I dealt with infections all the time, missed constant school days until I started getting treated. There are many weird and unknown complications that actually fascinate me more than scare me. Things like, well, a couple months ago, an 18-year-old died of early onset dementia, which we don't really know why that happens with XLA, but it gives a clue into how the immune system functions. And so I'm healthy thanks to monthly infusions. When you donate blood or plasma, they take your antibodies, which B cells produce, and I receive them. And so if you've ever donated blood or plasma, there's a good chance that I have some of your antibodies. And I actually, before I end, I received an email this morning, which kind of changed the way I wanted to end this. And I have to skip through this. But the email was from a patient advocacy group called the Jeffrey Modell Foundation. Jeffrey Modell was a 16-year-old kid. who passed away due to XLA complications a long time ago, and his parents started a patient advocacy group. And they asked me if I wanted to do an interview for them. And one of the questions was, do you feel defined by your condition? And I've always thought and answered that question, yes. But I don't want it to be that way anymore. I want you to think about your immune system a little bit more when you think of who you are. But I've always done it, and it weighs on me. And so now I think of XLA differently. And now I'm grateful for my immune system, for good health, for where it's brought me today, and for all of you. So thank you.